Welcome everyone. Today we're looking at 9.6, Transforming Parent Functions, Day 2. So last class we looked at transforming left and right and up and down. Today we're adding a few more transformations. So you might notice looking at the first picture, we are reflecting. So you see the same shape in both quadrants. So this is reflecting across that line. So has the graph reflected horizontally or vertically? Well, it is reflected across a vertical line. And that vertical line specifically is called the y-axis. So that is one type of reflection. So if you reflect across the y-axis. The second picture, you can kind of see it is reflecting across this line. So we call that reflecting horizontally. So it is reflecting across the x-axis, which is our horizontal axis. So how these transformations are created is if the x is being made negative inside of the function, that is going to reflect across the x-axis. And I said x, I meant y. Reflect across y-axis. Personally, I abbreviate that as a capital R with a lowercase y next to it instead of writing reflect y-axis every time. So that's what I would like. I don't know what your teacher will like. If the negative is on the outside of the function, it is going to reflect across the x-axis. And then again, personally for me, I abbreviate that to be a capital R with a little x, means reflect across the x-axis. You may want to check with your teacher to see if they also want that. All right, so we are going to practice identifying the parent function and then saying which type of transformation happened. So hopefully we know by now if I see a square root, that is a radical, and its parent function is square root of x. So that negative is inside the square root, so it is reflecting across the y-axis. Number 2, I see those bars, so that tells me it is an absolute value equation with the parent function absolute value of x. This time the negative is outside of the absolute value, so that is a reflection across the x-axis. 3, I see a 2 as the exponent, so that is a quadratic with a parent function of y equals x squared. So because that negative is not inside of parentheses, I consider that being on the outside, so that is a reflection across the x-axis. Finally, we have an e to the x power, which we know is an exponential. And the parent function is y equals a b to the x. Ooh, that negative is inside of the exponent, so that would give me a reflection across the y-axis. If it had been like a negative e to the power of x, that would have been a reflection across the x-axis. So that negative being in the exponent is what's telling me inside, kind of like the moving left and right. So looking at a graph, it says identify the transformation, then graph the reflection using the dashed basic parent function. So this first one, I see the negative on the outside, so that tells me reflection across the x. So this is my x-axis. So we're going to reflect those points across the x-axis. So the one on the origin stays on the origin, and the other points are all going to go the same distance across the x-axis. So that is a reflection across the x-axis. Second one, negative is still on the outside, so reflection across the x. Honestly, a lot of the reflecting we do is across the x. So if it's on the origin, it stays on the origin. The other ones are going to go the same distance across the x-axis. So this one is 1 up, so it goes 1 down, 2 up, 2 down, 3 up, 3 down. And that's giving me a nice radical transformation. Finally, 3, that is a reflection across the x again. So we're going to reflect that quadratic across the x. So that they're going the same distance away. So that one's up 1, 2, 3, 4, 1, 2, 3, 4. So we've got our nice U shape. So I know all those were across the x-axis, but if you notice down below, it says, why would the following reflections not be interesting? So why would it not be interesting to transform those across the y-axis? Well, if you look at an absolute value is that V shape. So if I were to reflect a V across the y-axis, it's going to look exactly the same. Same thing with a quadratic. If I reflect it across the y-axis, it's again going to look exactly the same. So why would it not be interesting? They would look the same reflected across the y-axis. If we had transformed the radical across the y-axis, that one would have been more interesting. So if we'd reflected that one over here, it would have looked something like that. So that could have been more interesting. All right, flip to the next page. Our final transformations we're going to learn about are called a vertical stretch and a vertical compression. So a vertical stretch happens when a is greater than 1, and a is going to be some number in front of the function. So if the number in front of the function is greater than 1, that creates a vertical stretch. And again, I don't really like writing vertical stretch every time, so I'm going to abbreviate that as a VS. And if that number in front of the function is between 0 and 1, so like 1/2, 2/3, 3/4, things like that, that creates a vertical compression. So a number between 0 and 1. And I'm going to abbreviate that as VC. All right, so let's try to identify some of these. So first we're going to identify the parent function. So I see an ln, so that tells me it's a logarithmic. Parent function being ln of x. Transformation, I see a 2 in the front. So 2 is greater than 1, so that's a vertical stretch by 2. Number 2, I see an x squared, so it's a quadratic. So y equals x squared is my parent function. And the 3 in the front of it is again bigger than 1, so it's a vertical stretch by 3. Number 3, I see an x cubed, so it is a cubic with a parent function of x cubed. So it's got a 1/2 in the front of it, so 1/2 is between 0 and 1, so that would be a vertical compression by 1/2. Number 4, I see a square root, which tells me it's a radical. So dy equals square root of x is the parent. And this 1/4 in the front tells me it's a vertical compression by 1/4. All right, number 5, I see an e to the x, which tells me exponential. So y equals b to the x is its parent function. And it's a 3 in the front, bigger than 1, so vertical stretch by 3. 6, I see an x. Biggest exponent would be that invisible 1, so it's going to be linear. So y equals x. And it has a 6 in the front, so vertical stretch by 6. H, I see the ln, so logarithmic, the hardest word for me to spell. Logarithmic. Parent function ln of x. And the 1/5 in the front is between 0 and 1, so that is going to be a vertical compression by 1/5. And finally, I see an x on the bottom of a fraction, which is a rational. So it would be 1 over x for the parent. So transformation-wise, this one's a little bit tricky, but 2 over x means that a 2 is being multiplied by 1 over x, and that's how that 2 ended up on top. So that would give me a vertical stretch, because 2 is bigger than 1 by 2. If it had been something more like 1 over 2x, that would be the same as saying 1/2 times 1 over x. So that would have been a vertical compression. So the 2 being on the top is what tells me it's a vertical stretch. All right, putting it all together. So putting it all together, we are now going to have multiple transformations happening in one equation. So we've got 4 different options. We've got left, right, up, down, reflections, stretches, compressions. So I guess it sounds like more than 4, but 4 types of ideas. So let's try it out. So first we're going to name them. So linear, y equals x. So I see a plus 5 outside of parentheses, so that tells me up 5. And I see a 3 in front of the x, which tells me a vertical stretch by 3. Up next, we have a radical. So it is a square root of x. This one has quite a few. So this one is a minus 3 in the back, so a down 3. A plus 7 inside the radical, so that's going to be a left, because the opposite of what I'd think, 7. And it has a negative in the front, which tells me a reflection across the x-axis. So we're kind of putting lots of things together. 3, the x is on the bottom, so I know that's a rational, which is a y equals 1 over x. That minus 5 in the back, it's outside the fraction, so that tells me down 5. The plus 3 inside of the square root, or inside of the fraction, tells me it's going to go left or right, so it's going to have to be left 3. 4, I see an x cubed, so it's a cubic. So y equals x cubed. That minus 9 in the back tells me down 9. The negative in the front tells me reflection over x. And the 2 in the front tells me vertical stretch by 2. So I know some people look at that negative 2 and they're like, oh, that's not bigger than 1. However, really, when we say bigger than 1, it's like the absolute value of a is bigger than 1, because that negative is telling me the reflection. The 2 is telling me the stretch or compression. All right, we've got a couple more. 5x squared is a quadratic. So y equals x squared. Plus 4 outside of the x is going to be an up 4. And a 1/4 in front of it is going to be a vertical compression by 1/4. 6, I see an ln, so that's going to be a logarithmic. So y equals ln x. This one's got a few different things going on, so that minus 9 is outside, so down 9. The plus 2 is inside the parentheses, so that'll be a left 2. And a negative in the front tells me a reflection over x. All right, up next we have an exponential. Got a minus 5 outside of the exponent, so that is a down 5. And a 1/2 in the front tells me a vertical compression by 1/2. And I forgot to say the parent function is b to the x. Finally, we have an absolute value. So y equals absolute value of x. That plus 2 on the inside tells me left 2. There's a lot of left 2's on this one. And the 3 in the front tells me vertical stretch by 3. All right, now that we are professionals at identifying transformations, let's try to create our own. So the last thing for this unit is we are writing our own functions. So you can either write these as f of x equals or y equals. I'm going to use y equals, but totally up to you. So they're going to tell us that we have a parent function of a quadratic, which I know is an x squared, and we want it to go up 3. So for our equation, we're going to have y equals, up 3 is going to be an outside of the x, so it's going to be x squared, and then a plus 3 moves it up 3. Number 2, it says cubic, which I know is an x cubed. Left 6 is going to have to go on the inside, and then reflected across the x-axis is going to have to be a negative on the outside. So we know we're going to have y equals, the left 6 has to go on the inside, so we'll have a plus 6 cubed, and then the reflection over the x-axis tells me it needs a negative in the front. Absolute value of x, we know it should be based off of that, and it is being vertically stretched by 3, so we know with 3 in the front, and then left by 5, so inside of the absolute value. So we'll have y equals 3, absolute value, x, Left 5 would be a plus 5. Four, we've got an exponential, so base would be b to the x. However, most of this unit, we've seen it as e to the x, so I'm going to write it that way. So this will look like y equals e to the x. And when it says right 7, I know that should go inside of the function, so it's going to be a minus 7 in the exponent. And then the down 4 is going to tell me outside of the function there should be a minus 4. So I know there's not parentheses in that one to show the left and right, but the exponent kind of has implied parentheses, that like that's happening inside of it. 5, we've got another quadratic, so an x squared, reflected over the x-axis, up 9. So x squared, to go up 9 needs the plus 9, and then reflection gives me that negative in the front. Rational we know is a 1 over x, so we've got y equals left 5, so that'll be on the bottom of the fraction, and then up 8 will be on the outside. So y equals x plus 5 plus 8. So that plus 5 is being inside of the function, so it's kind of like there's implied parentheses around that. All right, 2 more. So linear, so that's just an x, vertically compressed by 1/5 down 3. Okay, so vertical compression of 1/5, we've got 1/5 x, and then down 3. And finally, a radical, so square root of x, reflected over the x-axis, so that negative, right 6, down 7. So we've got 3 things going on. So in this radical, we know we're going right 6, so a minus 6, down 7 would be a minus 7 outside of the radical, and the negative in the front tells me reflection across the x. All right, we have done it. So you have now learned all the transformations we're covering in Algebra 2. So good luck, and I hope it goes well in the practice.